Space is a three-dimensional continuum containing position and directions. In classical physics, physical space is often conceived in three linear dimensions. Modern physicists usually consider it with the time to be a part of the boundless four-dimensional curriculum and continuum known as space-time. The concept of the space is considered to be one of the fundamental importance to an understanding of the physical universe. However, the disagreement continues between the philosophers over whether it is itself an entity, a relationship between entities, or a part of the conceptual framework. And the debates concerning the nature, essence, and the mode of existence of the space date back to the antiquity, namely to the treasures like the Timaeus of Plato or Socrates in his reflection on what the Greeks called it in the physics of Aristotle or the later geometrical conception of the place as a space coextension in the discourse on place. Like as many of these classical physiological questions were discussed in the reformer civilizations and reformulated in the 17th century, particularly during the early development of the classical mechanics. In Isaac Newton's view, space was absolute in the sense that it existed permanently and independently of whether there was any matter in the space. Other natural philosophers, nobility, that is Leibniz, thought instead that the space was in fact a collection of the relations between the objects given by their distance and direction from one another. In the 18th century, the philosopher and theologian George Berkeley attempted to refute the visibility of the spiritual depth in his essay toward a new vision towards this space. Later, the metaphysician Immanuel Kant said the concept of the space and the time are not empirical ones, derived from the experience of the world. They are the elements of already given systematic framework about the concept of the space and the time are not empirical, and these are the frameworks that humans possesses and uses to structure our experiences. Kant referred to the experience of the space in the qualities of pure reason as being as a subjective, pure form of intuition. In the 19th and 20th century, mathematicians began to examine geometrics that are non-Euclidean, in which the space is conceived as curved rather than flat. According to the Albert Einstein theory of the general relativity, space around gravitational fields divides from the Euclidean space. Experimental tests of the general relativity have confirmed that the non-Euclidean geometrics provide a better model for the shape of the space. Now we'll discuss about the philosophy of the space. Now, first of all, is Galilean and Christian theories about the space, matter, and motion are the foundation of the scientific revolution, which is understood to have the cultivated with the publication of the Newton's Principia Mathematica in 1687. Newton's theories about the space and the time helped him explain the movement of the objects, while his theory of space is considered the most influential in physics. It emerged from his predecessors' ideas about the same. As one of the pioneers of the modern science, Galileo revised the established Aristotelian and paradigmatic ideas about a geocentric cosmos. He backed the corporean theory that the universe was heliocentric with a stationary sun at the center and the planets, excluding the Earth, revolving around the sun. If the Earth moved, the Aristotelian believed that its natural tendency was to remain at rest as was in question. Galileo wanted to prove instead that the sun moved around its axis. The motion was an nature to an object as a state of the rest. In the other words, for Galileo, Aristotelian bodies, excluding the Earth, were naturally included to move in the circles. The view displaced another Aristotelian idea that all the objects gravitated towards their designated natural place of belonging, and this was a great This was an opening door for the knowledge of the space for the people. And now we'll discuss about the rain descrates. Descrates set out to replace the Aristotelian worldwide worldview with a theory about the space and the motion as determined by the natural laws. In other words, he sought a metaphysical foundation or a mechanical explanation for his theories about matter and motion. Aristotelian space was Euclidean in structure, infinite, uniform, and flat. It was defined as that which contained matter. Conversely, matter by definition had a spatial extension so that there were no such thing as empty space. The Aristotelian motion of the space is closely linked to his theories about the nature of the body, about the mind, and the matter. He is famously known for his cogito ergo sum, that is all the idea that we can only be uh, certain of the fact that we can doubt and therefore think and therefore exist. His theories belong to the rationalist tradition, which attributes knowledge about the world to our ability to think rather than to our experiences. As the as he posted a clear distinction between the body and the mind, which is referred to as the Christian Buddhism. Now we'll discuss about the Leibniz and Newton's view about the space. First of all, we will discuss about Galileo's. Following Galileo's and his creations during the 17th century, the philosophy of the space and time revolved around the ideas of the Gottfried Leibniz, a German philosopher, mathematician, and Isaac Newton, who set out two opposing theories of what space is, rather than being an entity that independently exists over and above that other matter. Leibniz held that space is no more than the collection of spatial relations between the objects in the world. Space is that which results from the places is no more than the collection of the spatial relations, and the space is that which results from the places taken together. Unoccupied regions are those that could have objects in them, and thus spatial relations with other places are understandable. For Leibniz, then space was an idealized abstraction from the relations between the individual entities are their possible locations and therefore could be continuous but must be discrete. Space could be thought of in a similar way to the relations between family members. All the people in the family are related to one another. The relation do not exist independently of the people. Leibniz argued that the space could not exist independently of the objects in the world because it implies a difference between the two universes exactly alike, except for the location of the material world in each universe. But since there would be no observational way of telling that how the space could not exist independently of the objects in the world it implies a difference between two universes exactly like except for the location of the material world in each universe. But since there would be no observational way of telling these universes apart, then according to the identity of the space, there would be no real difference between them. According to the principle of the sufficient reason, any theory of the space that implied that there could be these two possible universes must therefore belong. Newton's took space to be more than relations between the material objects and based his position on observation and experimentation. For a relationist, there can be no real difference between the inertial motion in which the object travels with a constant velocity and non-inertial motion in which the velocity changes with time, since all spatial measurements are absolute related to their objects and their motions. But Newton's argued that since non-initial motion generates forces, it must be absolute. He used the example of the water in a spinning bucket to demonstrate his argument. Water in a bucket is hung from a rope and is set to spin, and as that continues to spin, there will be no any chances of his falling, the of his falling. Like as if the bucket spinning is stopped, then the surface of the water remains concave in the Newton's argued it must be a result of the non-inertial motion that is related to the space relativity, very closely related, and between the and it is like the bucket water spinning in the bucket. It is stopped with the surface of the water remaining concave as it constantly becomes concave. If the bucket spinning is stopped, then the surface of the water remains concave as it continues to spin. The concave surface is therefore apparently not the result of the relative motion between the bucket and the water. Instead, Newton's argued it must be a result of the non-inertial motion related to the space itself. For several centuries, the bucket argument was considered decisive in showing the space must exist independently.